Hello everybody, hope you guys are all doing well and starting to get a little bit of a rhythm of what this class looks like and what the rest of your classes look like, especially when you're online. I know it's hard to keep a schedule and to keep a rhythm of what school looks like, but hopefully after 3 or 4 days now of class, you're kind of setting into a little bit of a routine. Today we will be looking at section 5.3, and that's going to be on page 218 in your book. Before we do that, I want to do a little bit of a review with what we've talked about so far and something that I mentioned, but we didn't spend a lot of time on. So, a little bit of a review. We've had a slide that looks very similar to this, and what we have been talking about is this idea of having functions and putting things in putting things, there we go, in function form, right? We've talked about that we have these x values. We also call those x values our domain. And something that we haven't talked about a lot is that we call the x values, or can refer to them as an independent variable, or the x is independent. And we'll see why we call those independent here in a minute. We also have talked about how we have y values, and we also talk about the y values being the range. All right, and something that we haven't talked about too much is that those y values are dependent. So the x values are independent variables, the y values are dependent variables. And the reason we refer to the x as independent is because we can choose any x. Right? Any x at all, we can just decide what we want it to be. In this case, we are choosing -1, 0, and 1. So we take those independent variables. If we start with -1, or those independent numbers, and we put it into our function, y equals 2 times -1 plus 1. 2 times -1 is -2, plus 1 would just give us 1, and that gives us a dependent variable because this y value is dependent on what our function is. And that's something, you saw those terms in lesson 5.1, but we didn't talk about them too much. So I just wanted to do a little bit of review of an independent variable is our x, because we can just choose what our x would be, and that's going to be its value. Our dependent variable is referred to as our y, or also we remember called our y our output. It's the same idea. So if we continued with this table, y equals 2. Now this time our x value is 0 plus 1. We would get our another dependent variable. Oops, and this should be -1. 2 times -1 plus 1 is -1. 2 times 0 is 0, plus 1 is +1. Y equals, if we put our third x value into our function, 2 times 1 is 2, plus 1 gives us 3. Nice job, Jack Johnson. You submitted your ed puzzle. Oh, he's not in this class, but so these would be our dependent variables, because I'll say it one more time, they depend on what our function is. They could change based on what our function is if we're dealing with different functions. And our independent variable is our x's, because we just choose those, or we're given those typically, and those don't change based on our function. As a little bit more of a review, if we take these numbers, those really give us coordinates on a graph. So that first one, we have the coordinate of -1, -1. With the second one, we have a coordinate of 0, 1. And the third group there, we have the coordinate of 1 and 3. So that's a very quick review of what we looked at for the most part in the first couple of lessons. And now today we are going to build off that a little bit. I know in our last lesson we talked about continuous and discrete variables, or continuous and discrete functions, and we will talk about that a little bit today, and that'll be important to have in the back of our mind. So again, today we're looking at lesson 5.3, linear function patterns. Our learning target for today, students will be able to write a linear function from graphs or tables. Students will be able to solve linear functions in real-life problems. So we'll look a lot at some graphs and tables in this lesson today. The application of it, the solve linear functions in real-life problems, that will come from your homework. You'll have a real-life problem there. So a linear function. A linear function is a function whose graph is a non-vertical line. So the opposite of that is a graph. So a linear function is a graph who has a non-vertical line. A vertical line would just be, if we have our axes, it would be something like this, or a line like this. That would be a vertical line. So this is not a function. A function is anything that is a non-vertical line, so it goes in the same direction the whole time. You guys have seen this form before. We call this slope-intercept form. Slope-intercept form, y equals mx plus b. In this form, our y is a variable, our x is a variable, but our m represents the slope of a line, and our b value is always going to be the y-intercept of a line. So let's talk about slope for just a second. When we're talking about the slope of a line, we're talking about the rise over run will be one way that we talk about it. Another kind of definition or another formula for slope is y2 minus y1 over x2 minus x1. And that looks a little bit complicated and a little bit tricky, but we'll break that down and it'll be no big deal. And then the way that your book talks about it on page 218 is it says the change in y over the change in x. So all three of these things are ways that you'll see me or your book or videos talk about slope. It's the rise of the line over or divided by the run of the line. This is more of the formula for the slope. And then another way to think about it, it's the change in your y values divided by or over the change in our x values. Now the y-intercept is just talking about if we have a function, or if we have a graph and we have a line that goes through our graph, our y-intercept is just talking about where our line crosses this y-axis. All right, so that's usually something that's straightforward, and you will see that in an example. So if we have this graph, this picture here on the right-hand side, and we want to write a linear function that represents this graph, we know that it has to be in the form y equals mx plus b. We know ahead of time that this is going to stay a variable and this is going to stay a variable. So we need to figure out how we're going to find the slope. We need to find the y-intercept. So remember, the slope is our m value and the y-intercept is our b value. So we need to find those two things to write an equation that represents, or a linear function that represents this graph. So let's start with the slope. If we are going to find the slope, I talked about this formula right up here, y2 minus y1 over x2 minus x1. And all that means is that if we have our line, we can kind of sketch in a line here. That's not bad. We need to just choose any 2 points that are on our line. Any 2 points. So let's say we choose the points four, 3, and 2, 0. Let's say we just choose those 2 points. You could choose any of them. I'm just going to choose those 2. Now, what I like to do, just so that I don't get things mixed up, is I like to label a few things. So we know that this is x and y, this is x and y. Now, it talks about in our formula up here, we have y2, y1, all that kind of stuff. So we're just going to choose one of these to be the first pair and one of them to be the second pair. So let's say, just because it goes in order, we call this x1 and y1, and this one is x2 and y2. It doesn't matter which order we want to go in. We just need to make sure that both of these are the 1 or both of these are the 2. Both of these are the 1 or both of these are the 2, that they stay the same in that ordered pair. So now let's use what we've labeled and put it into our formula. So we have y2, which is 0, minus y1, which is 3, over the top of x2, which we set our value as 2, minus x1, which is 4. Well, let's simplify. 0 minus 3 gives us negative 3. 2 minus 4 gives us negative 2. A negative over a negative, they just cancel each other out, so we have a slope of 3 over 2. Remember, this is also a way of saying the rise over the run. So if we look at this graph, let's say we start down here at 0, negative 3. According to our slope, we need to rise 3 numbers, so 1, 2, 3, and we need to run, or go to the side, left and right, 2 digits. So we rose 3, and now we go from here, we go 1, 2. Well, it looks like our slope is correct because we rose 3 and we ran 2, the rise over the run. So there's a way we can check it. Now if we look at our y-intercept, that is just where our line crosses this y-axis, or axis. And we can see that is right here at 0, negative 3. So that means our y-intercept is negative 3. Now we can always see what our y-intercept is because when our line crosses the y-axis, x has to equal 0. And that's kind of a clue to know that that's where our line crosses our y-axis, is when x equals 0. We'll talk about that a little bit more later. So if we put this whole thing together, if we are writing our line, we know we keep y as a variable. We have our m value, which we found, that's our slope. We have that right up here, 3 over 2. X stays a variable. And then our y-intercept plus a negative 3. If you wanted to write it in a different way, you could just say y equals 3 over 2x, and you could just drop the plus sign, x minus 3, and that would mean the exact same thing. But either way works for me. So that is how we would take a graph, a picture, and we would write write an equation in this linear form. I guess we're not writing an equation, we're writing a function. We're writing a linear function. Now another example, let's say that we have a table this time. We follow the same idea where we need to write it y in the form y equals mx plus b. Our y value and our x value are going to stay a variable. So we just need to find our slope and our y-intercept. For finding slope, let's say we choose the 2 points. Again, we could choose any 2 points. Let's say we choose -3, 9. Oh, nice job, Luca. Turned in your Ed puzzle. Let's say we choose -3, 9, and we choose our other point to be -1, 5. Now I'm going to go ahead and label these. We'll just call this one x1 again because it's the first one, y1, x2, y2. Now we know that we need to do y2 minus y1, which is 9, over the top of x2 minus x1. Five minus 9 gives me -4. -1 minus -3, so really -1 plus 3 gives me 2. So this gives me a slope of -2 over 1, and that's totally okay to not write it in fraction form and just write it as -2. And we just know that on the bottom that we have rise over run, that our run is 1. If we just write it as -2. So we have slope of -2. Now our y-intercept. Well, this time we don't have a graph to look at. We could graph all these points, which a lot of times I would do just because I like that visual. But if you didn't graph all the points, the clue that we would want to look at to see, okay, what is our y-intercept, again, is when x equals 0. Because say we were only to graph that one point. So at 0, positive 1, 2, and 3. Well, when x equals 0, our line has to go through this point, and that's going to be the intercept right there. So we can see our y-intercept is just positive 3. Again, if you wanted to graph it and you wanted to see the line go through there, absolutely go ahead and graph those points. But you can also just look at the table and see where x equals 0. Now if we put it all together, y equals m, which is our slope, times x, plus our b value, our y-intercept, plus 3. We can check our equation. I'm not going to go through all of it right now, but we could check it if we were saying, this linear function seems a little bit off, or something went wrong. If we wanted to plug in one of our x values up here, say we wanted to plug in 0, then we should get our y value that corresponds with it. We should get 3. So just if you were to quick plug in 0, because that's an easy one, so -2 times 0 is 0, plus 3 is 3, saying that y equals 3. That matches our table up here. So we know that our linear function that we just wrote is correct because we tried one of our x values and we found that it corresponded with the correct y value. So that's a quick way to check. All right, now it's your turn. So your job is to write a linear function that relates y to x. And that's what we did right here. We took y and we said, all right, how does y relate to x? Well, y relates to x by doing -2 times x plus 3. So pretty much writing that linear function. So this is where you would pause the video. You'll need to find the slope, the y-intercept, and then write your equation. So go ahead, pause, give it a try, and press play when you're done. Welcome back. we know we need an equation in this form, that we need to find our slope, and we need to find our y-intercept. We start by finding our slope by just taking any 2 points on this graph. So any 2 points. If you didn't take the same 2 points as me, we still will get the same answer if we do it correctly. So if we take 0, -1 as one of our points, and then let's just take 2, -2 as my other point. So my points are 0, -1, and then my other one is 2, -2. Now, just like I have been doing, I'm going to label these just so that I don't mix them up, keeping that consistent. y2 minus y1 over the top of x2 minus x1. -2 minus -1 is really -2 plus 1, so we have -1 over 2. Oh, no equals. So our rise is -1 and our run is 2. And we can double check that again. So first, does the negative make sense? Yes, the negative does, because our graph is going in that negative direction. Our rise, if we look here, our rise up 1 over 2, that seems to match up. So we have a good slope there. Our y-intercept, we want to look for where x equals 0. We can see that that is that point right there on the graph where it crosses that y-axis, and that is at -1. So let's put it all together, and you should have got, again, even if you chose different points to find your slope, you should have gotten y equals -1/2 times x plus a -1. Or if you wrote it like this, totally fine. So that is the first one. If you did not get that correct, go back through your work, check your work. Even if you chose different points and you got it incorrect, double check your work to see where something went wrong, because we should get the same answer. If you try different points and you can't figure out where it went wrong, send me a picture and I can help you out. So this time, again, we're writing a linear function that relates y to x, but this time we just have the table. So like that second example that I did. So again, go ahead, choose any 2 points, find the slope, find the y-intercept, and write your equation. All right, welcome back. Y equals mx plus b. I'm choosing any 2 points for my slope. Why don't this time I choose -1, 1 and 2, 4. So the 2 endpoints there. So my points -1, 1 and 2, 4. x1, y1, x2, y2. Four minus 1 over 2 minus -1. 2 minus -1 will give me 3, so you should have gotten a slope of 1. And our y-intercept is right here where x equals 0. So our y-intercept equals 2. So then our equation should be y equals 1x plus 2. If you want to forget about the 1 and just say y equals x plus 2, that would be totally fine as well. All right, I have one last example I want to look at, and this is one that I just want to show. So hang with me, this is just one kind of abnormal thing that I want to show. If we look at this table, we notice right away that all of the y values are the same. All of them are 2. If we were to graph this, that means we would have -2, -2, 2, -1, 2, 0, 2, and 1, 2. So it would look something like this. It's just a horizontal line. Now, the reason I bring this up is because we might see a horizontal line and think, can we write a linear function for that horizontal line? Because we talked about vertical lines don't work. So what about a horizontal line? Oh, nice job, Mia. Turned in your ed puzzle. Way to go. So what about a horizontal line? Well, let's take a look. Can we get a slope of this line? Well, the rise is kind of 0, and the run is kind of 0, but let's see. If we choose our points to be 0, 2, and 1, 2. x1, y1, x2, y2. And I do write those things almost every single time because I used to get those mixed up all the time. So 0 over 1, that's undefined. That doesn't work. So we don't have a slope necessarily, but we could say, but do we have a y-intercept? So if we're writing our equation, y equals mx plus b, oops, I'm sorry, this is 0, not undefined. That is 0. So we know that y equals our slope is 0 times x, so that's going to be 0. But can we have our plus b value? Well, it crosses the y-intercept at 2. So for this one, all the equation would be is y equals 2. So we won't see that very often, but that is kind of the math behind it right here, is that our slope ends up being 0, so we can't even have really anything besides y equals 2. So horizontal line does work. Nice job, Trey. Oh, Trey's not in this class. But people are turning stuff in like crazy this morning. So that is just an oddball out there, but you'll see it once in a while. So horizontal lines, we can, in fact, write an equation for. Vertical lines, we still can't. Those won't work because we don't have a slope. Well, in that case, our slope is undefined, and we don't have a y-intercept. So our learning target. Students will be able to write a linear function from graphs or tables. Well, we went over that a few times. I showed a few. You guys tried a couple. I think we're good there. Students will be able to solve linear functions in a real-life problem. And that is something that you will practice on your homework. They'll have you write a linear function in the context of some type of problem, and then they will probably ask you to say, all right, you wrote your linear function. Now, Lucy has 30 cookies that she sold. How much is it going to cost? And you'll have to plug some number into your linear function to solve that real-life problem. Nice job hanging in there and listening to this lesson. I know that it's difficult to watch a 15 or 20 minute or even over 20 minutes sometimes, but that long of a video. But hopefully we won't have to do this for too long, and we'll get to be back in person, and we'll have a lot of fun then. So anyway, have a good rest of your day. If you have any questions,